Your stomach needs a special kind of acid to break down the food you eat. Why is having just the right level of acidity so important for digestion? Have you wondered these questions? So let's start acid bases and salts of class 10th chapter. This is very informative and knowledgeable chapter. So let's begin. What are acids? An acid is a substance that produces hydrogen ion when dissolved in water. When acid or ionic compounds dissolve in water, they break into smaller particles called ions, which is called dissociation. Example, hydrochloric acid dissociates into H plus and Cl negative ions. Acids have a sour taste and they turn litmus paper to red. Types of acid: strong acids. An acid which dissociates completely or almost completely in water are called strong acids. Complete dissociation is when a fully breaks into its individual ions in water with no intact molecule left. Hydrochloric acid fully dissociates and it is called a strong acid. Types of acid, and it's a weak acid. Acid that dissociate only partially when dissolved in water are called weak acid, for example oxalic acid and lactic acid. What is base now? A base is a substance that produces hydroxide ion when placed in water. When bases or ionic compounds are dissolved in water, the ion dissociate. For example, sodium hydroxide NaOH and potassium hydroxide KOH. Bases are substances that are bitter in taste and soapy in touch and they turn litmus paper blue. Now, strong bases. Strong bases are those which ionize in water completely and produce a large number of hydroxide ion, for example, NaOH and KOH. Weak bases are those substances that partially ionize in water and produce a little amount of hydroxide ion, for example, NH4OH. So, reaction of acid and bases. Acid and bases react with metal. Acid and bases react with metal to form salt and release hydrogen gas. For example, zinc with sulfuric acid gives zinc sulfate and hydrogen gas. Here, zinc dilute sulfuric acid gives zinc sulfate and hydrogen gas. NaOH and zinc gives Na2ZnO2 plus hydrogen gas. Acid and bases react with metal carbonate and metal hydrogen carbonate. So acids react with metal carbonate and metal hydrogen carbonate to form salt, carbon dioxide and water. Sodium hydrogen carbonate and acetic acid give sodium acetate, carbon dioxide and water. Now reaction of acid and bases gives neutralization reaction. Acid and bases react and form water and salt. For example, NaOH plus HCl gives NaCl plus H2. So acid and bases react together, form salt and water. Reaction of metallic oxide with acid and bases. Metallic oxides with acid produce salt in water. Metallic oxides are basic in nature. Check the reaction below. Reaction of non-metallic oxide with acid and base. Non-metallic oxides with bases produce salt in water and non-metallic oxides are acidic in nature. Note down the example. Now common characteristics of acids and bases. Both can conduct electricity when dissolved in water called electrolysis. They can react with each other in a neutralization reaction to form salt and water. Can be strong or weak depending on ion production in water. Used in various chemical application like acid in batteries, bases in cleaning agent, etc. Indicator of acids and bases. Indicators are substances which when added to an acid or base change color and help decipher the nature of the substance being tested. For example, natural, synthetic, and olfactory. Natural are turmeric and litmus, synthetic are methyl orange and phenolphthalein, olfactory are clove. Natural indicators are originally found in nature, known as turmeric and litmus. Synthetic indicators are indicators which are synthesized and created by chemical process. For example, methyl orange and phenolphthalein. Olfactory indicators, their smell and odor changes when mixed in acid or basic solution. For example, clove and onion. Now, how strong are acid and bases? The amount of H plus ion present in a solution can be measured by using a universal indicator. It shows different color at different concentrations of hydrogen ions. A scale for measuring H plus ion concentration in a solution is called the pH scale. Here, the pH lower starting from 0 and higher to 14. So it ranges between 0 to 14. The higher the hydrogen ion concentration, the lower is the pH value. That means the most acidic has lower pH value, like in lemons, which are sour in taste, and neutral one has 7 pH, that is water, and soup or some other juices have pH 14. Importance of pH in everyday life. pH levels greatly influence plant and animals. Specific pH range are essential for enzymes, hormone activity, and digestion. Optimal soil pH for plant growth is 6.5 to 7. Optimal digestion in the stomach require a pH range of 1.5 to 4. Hydrochloric acid present in the stomach affects enzymatic reaction in food breakdown. Tooth decay can also occur when the pH around teeth drops to 5.5 or lower. What are salts now? It is defined as a substance that is odorless, salty in taste, and soluble in water. Its pH value is equal to 7. For example, sodium chloride NaCl. It is commonly known as table salt or Epsom salt MgSO4. It is used as a bath salt. Neutralization reaction with example acid and base give salt and water. So pH of salt, salt of strong acid and strong base are neutral with a pH value of 7. Both are strong HCl and strong base NaOH give neutral salt and water. Because both are strong, so salt nature is neutral in nature. Now, salts of strong acid and weak base are slightly acidic with a pH value of lesser than 7. Here, strong acid react with weak base, give acidic salt and water because the acid nature is strong. So, salt nature is also acidic. Here, the weak acid and strong base are slightly basic with a pH value of greater than 7 because here is acid is weak and base is strong, so salt nature is also basic in nature. Now salt is used in our everyday life, and the most basic example is common salt. We already know common salt is used for many day to day purposes like cooking, even in preserving food items.